Hello, in this video we will see how static data members works in Java. Static data members are also called instance member and they share same memory location. Yeah, as already told, static data members are also called as instance variable. So they are specified using the keyword static. Here in this example, you are seeing the keyword static. So without that, the line reads as a private string car name equal to new name. That means the variable name is car name, data type is string, and its access specifier is private. We can say private scope. Here, once we specify the static, that means it states that there is a variable called car name and it's an instance variable and it is at class level. That means all instances of the class will share this same location. So this member actually belongs to the class itself. That means it doesn't belongs to or it doesn't specific to a particular instance of your class. Since it does not belong to a particular instance of a class, all instances share this same location. Here in the below picture, you are seeing a car class and it has a static member car name. So if there are 5 instances of this class C car, all 5 instances will share this same location. That means all instances will share this same car name. So if object 1 changes the car name, then object 4 will see that. All global variables are created in the data segment. Likewise, the static members also get created in the data segment. So we can say it's global with scope given to a class. Alright, we will see this with an example. Here first we have a class called CCar, and inside that we declared a static variable car name. You can see that in code snippet 01. Void main is empty for now. So here the member is public. That means the static member can be accessed inside the class and even outside the class. Since it doesn't belong to a particular member and since the scope is public, one can access it outside the class with the class name itself. We will see that soon. So here the class name is a person, so it is a completely different entity and it has a method called print car name. So inside the method we are accessing the static variable car name by specifying the class template name. Here in this statement, CCar is the class template name. Then we are placing a period and accessing the static member. So if there are multiple static members, all can be accessed the same way. That means we don't need to create any instance. The class name itself enough to access the static members inside it. So after that, in the main class, we are creating 3 instances of person. Then we are printing the car name. So here car name is not initialized. When we are in Eclipse, we will initialize the car name. Then we will check how all three instances access the same location car name. So here the car name doesn't belongs to person P1, but we want to prove that we create three instances of P1 and all will have access to that car name. That means here the car name is acting as a constant, I mean a scoped constant. That means the constant which is in the scope of a C car, since it is public, with the C car we can access it anywhere in the application. Okay, there are three instances, P1, P2, P3, and we will see how that works in Eclipse. So here is our person class, and we are saying car name is, then we are printing it. And if you see here, when we are declaring the car name, that time itself we specified a name. Then in snippet 3, we are creating three instances of a person, and we are printing the car name. After that, we attempt to create the car itself, C car itself. So here there are two instances of car 1. First, through car 1 we are changing the name, so it's Audi. Then we are printing the car 1 name, or I can simply put car name since it's common for all. Here through car 1 we are accessing the car name, and through car 2 also we are accessing the car name, and we will see what is the output here. So it is printing BMW because it is initialized here. So since there are three different instances, and since it is allocated in the data segment and global, you can see it in P2 also. When we print P2, it still prints BMW. P3 also prints BMW. Now car 1, new car. Then I'm creating one more new car. Then through here in the person class, we doesn't create any instance of a C car, but we still access the static member. Then we access the static member and printed that. Here we are still accessing the static member and changing its name as Audi. So here it looks like the car name belongs to a particular instance car 1, but that's not the actual case. Since this is the template C car, there is only one instance car name. So now if you print, it will print Audi. Now let's print once again through P1. Now if you see, P1 also prints Audi. That means that since there is only one location, all the instances will share that same location here, even though the member belongs to C car. Since it is shared by all the instance, car 1 and car 2 both share that same instance. That's why we saw Audi here when we printed it through car 1 and car 2. Then it can be accessed anywhere. That's why we saw how it can be accessed in the print car name function. So in the print car name function, without creating the instance, we directly accessed it through a class template itself. So that's all here. Thanks for watching. See you.